We are going to see an overview on database transactions in MongoDB. This will be a developer's point of view and not a in-depth theory into the database. So let's start with asset properties. Almost every developer knows about the asset properties, that is atomicity, consistency, isolation, and durability. Here we are taking a deep dive into the atomicity. Atomicity is basically when you are doing multiple operations on a database, either all of them executes or none of them executes. There is no partial execution of the operations on the database. So yeah, atomicity basically follows the rule either all or none. Let's go to the MongoDB documentation on transactions. Here it is written that in MongoDB, an operation on a single document is atomic. For example, if we want to update the multiple records in a document in a MongoDB, we use the operation update many. If we want to insert many records in a single document, we use the operation as insert many. Those operations are atomic in nature. That means either all of them are updated or all of them are inserted, or none of them is inserted if there are any error. So basically that is by default in a single document operations. But when we have for situation that require atomicity in operations on multiple document, MongoDB supports transactions. Just not on multiple document, we can even use the transactions on multiple operations, collections, databases, documents, and shards. Yeah, so for let's take an example. Let's say we have a one database in that there are two documents. One is for post and another for analytics. For every post we add, we also update our analytics together. So in one transaction there will be one post added and one analytics update. So let's say we are doing this without transactions. First we'll add the post and then we'll update the transaction. Let's say if there is any error in the analytics or any error in the database connection, if the post is added and analytics is not updated, the database goes into the inconsistent state. That means we are losing on the property of consistency. So in order to maintain the consistency, we make use of transactions. In MongoDB, transactions is used by the callback API. These three steps of the callback API, that is, first it starts the transaction, then it executes the operation, and then commits the result if it is successful, and if it is not successful, it ends the transactions without committing. So let's see this in the diagram. Yeah, basically this is how data flow of the transactions. First it starts the API, then it starts the transaction, then it executes all the operations that we want. If the operations are successful, it commits the result into the database. If even one operation is not successful, it ends the transaction with an error and it do not commits the result into the database. We can make use of the analogy of Git for this. In Git, how we roll back changes, commit the changes and roll back changes. Similar thing happens here. I made one diagram for that. Let's say this is your main database and it is in the state A. For every time for transactions we start this session, we execute an operations. If any error is there, we roll back about the transaction and we roll back changes and the database goes back to the state A. If all the operations are successful, we commit the changes into the database and the database state goes to the state B, and then we will end the session. So here we can see the transaction is happening on isolation. That means it is invisible by till the time it commits any updates on the database. So we cover our third principle there. Yeah, so let's see how does it how we will implement it. In the MongoDB documentation, they have given the implementation. I have a concise implementation. So yeah, every time we will use a client in MongoDB, then we will connect the client. For transaction we'll use the start, every time in transaction we use sessions. So yeah, we'll start the session, then all the operations are wrapped into a try catch block. In the try we will list, we'll start the transaction, and then we'll try to execute all the operations. If all the operations are successful, we'll commit the transaction, and our try block will be executed. If any operation throws an error, we'll go into the catch block, and then we will abort the transaction. That is and you can do anything you want with the transaction with the error. And then finally we will end the session and we'll close the client. Okay, client closure is optional, not necessary. So this is the basic structure. First we will start the session, then we will wrap our transaction into a try catch block. We'll start the transaction, execute operations, then if all the operations are successful, we'll commit the transaction. If any operation throws an error, we will abort the transaction, and in the end finally we will end our session. Yeah, so let's see this in a practical manner. I have one example for this. I have a database MongoDB Atlas rolled up for this demo overview, and I have two documents. One is analytics and another is a post. You can see right now there are 4 posts inside the posts, and there are one analytics that says total post. Okay, here total post is 7. Of course our database is inconsistent, but let's take this for an example. And I have created 2 files here. One is using transaction and one is using without transactions. So let's see the without transaction part. Yeah, first we will create the post here, and then we'll update the user with post 1, increase the post 1 basically. And in the transaction we are starting a transaction inside the try catch block. Then we'll create a post, then we will update the analytics. And as we discussed, there is a catch block and a finally block. So first let's run this transactions without transaction update operation. Yeah, so our post was created successfully and analytics was updated successfully. Let's go to the Atlas and check. Yeah, it is updated to 8 from 7, and the post is updated from 4 to 5. Now let's add an error in between. Let's add an error after the post creation. Throw new error, analytics update failed. So let's run this. Okay, you can see that the post is created, but the analytics update is failed. Let's see that in Atlas. See, earlier the post was 5. Let's refresh this. Now the post is 6. And now earlier the posts were 8. After refresh also it's 8. That brings our database into inconsistent state. So yeah, this is what happens when we do not implement transactions. Now let's implement transactions. First we'll run this without throwing the error. So let's run the transaction. So yeah, we can see that post is created and the transaction is committed. Let's refresh. Okay, there were 6 posts earlier, now there are 7, and the analytics says the total posts were 8, and after refresh it says 9. So let's add a error in between this, and let's try to run it again. So you can see that the post is created, but the analytics update was failed, so we are aborting the transaction. So yeah, you can see that earlier the posts were 7, and after refresh also it's 7, because we aborted the transaction because our analytics update was failed and it was in a single transaction. So this was the practical demo on transactions. And one thing can be noted, that there are few restricted operations on transactions. That is yeah, the following operations cannot be implemented on transactions. And also we need a replica database for transactions. If I right now spin up the Docker for MongoDB and try to run transactions on it, it won't. Okay, so this was it. We'll meet